Sorry for the confusion. Without much further ado, let's get started with breaking some echo chambers. We have with us Mr. Michael Gord. So, where do I start? Entrepreneur extraordinaire and innovator par excellence. Michael Gord, our keynote speaker for today, requires no special introduction. Design, project management, technical writing, web development. He is a master of all trades, but blockchain is his acme. A blockchain developer focused on building decentralized applications, Michael is the founder and CEO of MLG Blockchain Consulting Canada, founder of Bitcoin Canada, and member of the board of Blockchain Association of Canada. It is only befitting that this Kela 2017 be kickstarted by someone who truly stands for breaking echo chambers and expanding horizons. Let me also add here that this is Michael Gord's first visit to our country. Ladies and gentlemen, let's join together in welcoming Mr. Michael Gord, our keynote speaker, onto the stage.
So can anyone see the cart in this picture? Raise your hand. See it? You can see it? Nice. I couldn't. 13 years later, this is a story. This is a picture from New York on Fifth Avenue. As you can see, where's the car? I mean, where's the horse? So in 13 years, Fifth Avenue in New York went from entirely horses to almost entirely cars. You can see there's the horse. I mean, here's the car, and here's the horse. Customs. But if we go into a little more detail, there are different types of disruptions. There's iterations, which is doing the same thing but better. There's innovation, which is doing entirely new things. And then there's disruption, which is doing new things that create new market segments and eliminate the previous market segments. So a couple examples of disruption are the light bulb being disrupted, or the candle being disrupted by the light bulb, and as we spoke about a little bit earlier, the cart disrupting the horse. And after disruptions take place, the previous category, so candles, and the previous category of horses for transportation no longer have a place in the market. So another trend that we notice with disruption is that experts tend to not be the ones to accurately consider disruptions. So if an example from 1980 is AT&T, which was at the time the largest landline, hired McKinsey to estimate the global market size of cell phones by 2000. And the McKinsey forecast was that in 2000, there would be 900,000 cell phones in the marketplace. And their suggestion to AT&T was that this market segment is not large enough for you to consider it and for you to be investing towards it. Any guesses on what the actual market size of cell phones in 2000 was? Feel free to call out. So the actual market size for cell phones in 2000 was 109 million, and McKinsey's estimate was less than 1%. There are tons of these examples, though. But continuing with this one, AT&T's landline market was disrupted, and they ended up acquiring a cell phone provider for $12.6 billion a decade later, and they missed out on a $1 trillion opportunity, which was cell phones. So you can see on the right side, it's just a list of some of the mobile businesses and their market capitalization. So second observation is that 99% of the world, experts included, have no idea what is about to happen and don't appreciate or understand the implications of disruption. So let's talk about some trends. So as we mentioned, experts don't often notice disruption happening and don't often predict it accurately. So here are a few other examples. In 1995, Robert Metcalfe believed that the internet would collapse the following year, with no foundation behind the thought. In 1997, Ken Olsen believed that no one would really want a computer in their home. In 1903, Scott Montaigne believed that the introduction of motor cars would still, or the horses would still have a use case for transportation after the introduction of motor cars. And as we know, all of these predictions by experts turned out to be hugely false. And these experts are still trying to predict disruption and are still failing. So if we look at today, here are a couple examples of quote-unquote experts predicting the death of Bitcoin. We're not going to be talking, this is the only time we're going to be talking about Bitcoin and blockchain, actually, for this discussion. But MoneyGram predicted that Bitcoin will fail to disrupt remittances. And as we see, Bitcoin is continuing to grow their percentage of the remittance industry. The CEO of JP Morgan believed that people are wasting their time with digital currencies. There would be no currency to go around that went around government control. And as we can see, a couple years later, there are now thousands of digital currencies that are existing without government control. Bitcoin core developer Mike Hearn, after he left the Bitcoin core team, announced that Bitcoin was a failed experiment and that it was going to zero. And as we can see, that did not happen. Seeking Alpha, one of the most recognized investment journals or investment websites, predicted that Bitcoin can't serve as a currency. And a couple of years later, they actually created a new brand called Seeking. I can't remember what it was. Seeking something that has to do with it. It's entirely focused on digital currency and blockchain investments. And the Financial Times predicted that Bitcoin would go to zero after it crossed 1,000. A couple more examples of experts with wrong predictions. CTO of Microsoft predicting that Apple will be dead. And Thomas Watson, president of IBM, predicting that the world market for computers would be less than 5. And one of the executives of 20th Century Fox predicting that the television would not capture any significant market share. So, as we can see, experts aren't necessarily the best at discovering disruption. This might be because they're focused on their current industry, and they don't want to suggest that their current industry is not going to have the same pull that it has previously. But I think we can definitely agree that it's not experts that are always predicting disruption. A couple of the reasons why disruption is happening now, we're going to talk about. So Moore's Law states that every 2 years, the annual improvements for the number of transistors that can be on a microprocessor doubles every 2 years. Oh, and then you add in Kreider's law, which is that the data storage on a hard drive goes down by 50% every 18 months. So in the last 60 years, hard drives have progressed from holding very minimal amounts of information to being able to hold terabytes of information in your pocket. And this has led to smaller and more efficient media storage and larger and more exciting developments in technology. And then there's Hendy's law, which is that pixels get 59% better each year for every dollar spent. So if you put all this together, it's created an explosion in the PC, internet, and phone industries. 10 years ago, these industries didn't exist. There was no cell phones, there was no Wi-Fi, and there was no real personal computing industry. And 10 years later, I think we all have laptops, we all have cell phones, and we all use Wi-Fi. And it's gotten to the point where if you're in the jungle in Thailand or the desert in Australia, we have Wi-Fi, we have cell phone connection, and we have internet connection. So a third observation is that there's currently the largest conversion of exponential technologies in history. So it's not a single disruption that's happening. It's many disruptions happening across a large number of industries that are happening at the exact same time. So now we're going to talk about some implications and opportunities. So this is a great story that Andrew Filipowski actually talked about at the North American Bitcoin Conference in January, and it's that it's the second half of the chessboard story, which is what we're entering with tech disruption today. So a long time ago in Egypt, the person that I think in Egypt at least, the person that invented the chessboard was given a wish. He or she could ask for whatever they wanted, and the person chose to get a single grain of rice for the first square of the chessboard, and for every subsequent square of the chessboard, the number of rice would double. So on the second square of the chessboard, there would be 2 rice. And every day it would double. On the third square, there would be 4 rice. On the fourth square, there would be 8 rice. Until on the first half of the chessboard, there would be 5 billion grains of rice, or about 100 kilograms, which is a lot of rice. But the second side of the chessboard is when it really starts to get exponential. On the second side of the chessboard, there would be whatever large number that is of grains of rice, and creating a pile of rice that was larger than Mount Everest. So the person that suggested this was killed by the king, apparently. Is how the story goes. So this is what we're seeing with the tech industry. We're about to get, or we are at the second side of the chessboard with the entire tech industry. So as you can see, throughout history, we've had steady innovations, and we're about at the tipping point where the innovations are about to get so fast that we can't keep up with them. So we're right there. So a couple of examples of how we're at the second side of the chessboard for the tech industry. So in India, the first 4G service provider came out in 2016 after a $20 billion investment into infrastructure and the network. And this is going to speed up data transfers in India so much that sending a 5 megabyte file is going to take 20 seconds rather than 8 minutes. So this revolution will transform the way that business is done in India, the same way that the automobile changed how business is done in America in the early 1900s, and how the bullet train changed how business was done in Japan in the 1800s, by speeding up how business is able to transfer across the country and across the international community a lot faster. But then continuing with the second side of the chessboard, the introduction of 5G is going to make it 100 times faster than 4G to be able to transfer data, which will lead to major innovation, major growth in industries like self-driving cars, VR, and the Internet of Things, which traditionally require very large bandwidths to be able to operate. And by 2020, it's expected that there will be 50 million connected devices worldwide. When we consider smart fridges and smart washing machines and smartphones and your smart Alexas. So with the introduction of 5G, it's expected that all of these devices will be connected, and will create massive innovation a lot faster because of how fast we can process data. And this isn't science fiction. It's expected that introduction of 5G is going to move into production this summer. So, like, actually any day now, there's going to be the first introduction of 5G, I think, in Austin, in the US. But once it's introduced, it's probably going to catch on very quickly. So here are a couple disruptive technologies that we need to be keeping an eye out for in 2017. The Internet of Things and sensors, as we mentioned before, it's estimated that by 2020 there will be 50 billion internet-connected devices, and the number of sensors is going up exponentially, and the cost to implement these sensors is decreasing exponentially. AI, machine learning, and deep learning, we're getting so good at developing technology that we're developing technology that can develop technology and can learn how to develop technology. So an example of that is Google languages, like technology that allows you to connect or to translate languages from one another. It's getting so good that it created its own language that only Google Translate or only Google languages can understand. The reason for that is that there are some words that are in different languages that don't translate 100% into from one language to the other. So Google created its own language, or Google AI created its own language to be able to process these words in a more effective way. Our robots are getting increasingly smart and increasingly good at doing non-trivial tasks. So 10 years ago, robots could only have one function, and they could, for example, make a cup of coffee. But now you can program robots to think and to learn how to do things. And you can show robots how to do things, and then the robot can understand how and start doing it itself. Solar panels or solar power and energy storage. With Tesla leading the way in this, we're getting so good at harnessing electricity and storing it that solar panels are decreasing in cost so exponentially that it's expected that eventually we're going to be using mostly solar for our electricity. Autonomous vehicles. So that's not just cars. That's tractors for construction. That's many pads for storage units. It's not just to transfer humans, it's to transfer objects. So with autonomous vehicles, it completely disrupts not just the taxi industry, not just the driving industry, it disrupts the storage industry, it disrupts every industry that involves moving items from one place to another place. 3D printing and 3D visualization VR. So we talk a little bit more about all these later on, and we give some actual concrete examples of each of these. But we're now able to 3D print human organs, and we're able to take pictures of a 3D environment and present it on a computer and in a VR landscape. Drones, rockets, and nanosatellites. We're developing aerial technologies that we haven't even created words for with drones. The first drones actually delivered the first food package. It was an A&W delivery. I can't remember where it was, but drones are now being brought into production in North America to deliver food. And these micro drones will be able to fly into our bodies and gather information that was traditionally impossible to get without these new inventions that we're creating. And last, digital currency and blockchain. We can now send money internationally for free. Sending money is a transaction of bytes, and sending movies is a transaction of gigabytes. And I can send a movie but it has a awesome property where if you stretch it but we have printed hearts for mouses, which start beating upon completion. So going back to the exponential parts of the second side of the chessboard, we're just at the second side of the chessboard. This technology exists. It's not mainstream and it's not production ready for humans, but consider how fast this technology is going to grow and what's going to happen once this is in production for humans. The rise of super apps and big data. So in North America, there were tons of social media applications that were developed in the early internet days, like Facebook and Twitter and Instagram and PayPal and Yelp. There were a bunch of copycat apps, let's say, in China that all the applications that the Chinese firewall deemed as not being able to control were banned in China, and they created their own applications, which grew to hundreds of millions of users, and now these applications have become super applications, where you can do everything that we do with applications in North America from a single application. So WeChat allows you to message friends, like WhatsApp or Facebook Messenger. It allows you to share updates, like Facebook or Twitter, post pictures, like Instagram or Flickr, make purchases, like PayPal, transfer money to friends, like a bank transfer or digital currency, order food from restaurants, like Uber Eats, review restaurants, like Yelp, and dozens of other applications. So what this means is that a single company has the I knew that we had created. I saw a video where we, I guess, bred a chicken egg outside of the egg using plastic, and the egg embryo grew into a real life chicken. But I saw a video of on the right we have human embryos outside of the woman's womb, where we can grow children outside of a human. There is I guess a hatch where we can feed them, so it allows you to grow your baby outside of you. The human womb, or outside extra womb, is just a concept right now. It's a prototype, but it's worked with chickens and it's worked with lambs. So it's going back to the exponential part of tech disruption. This working with humans is not very far off, and it's expected to move from the lab to field tests this summer. So a fourth observation is that we won't experience 100 years of progress in the 21st century. It'll be more like 20,000 years of progress at today's rate because of how exponential the technology is growing. So what does this mean for us? This change is happening. We can't do anything about it, and we can't stop it. There's a convergence of tech disruption across just about every industry that we work with today. The only thing we can do is be aware of the change, be aware of the disruption, and be on the side of innovation rather than on the side of, rather than behind the curve. Thank you. Any questions? Yeah.
Michael, I am not a Luddite or a tech-based person. My concern is about I am scared of the convergence of exponential levels of convergence or disruptive technologies. And a time will come when there will be no jobs left for our youngsters all the world over. There will be no job. Jobless growth are the final result in that singularity. My concern is, as Bill Gates predicted, there will be a time will come when there will be no purchasing power with the peoples and a universal minimum wage support will be given to them. And what is your take on it? And regarding, you predicted that there were poor predictors in previous times. But my take is that people like Isaac Asimov and Arthur Clarke were having a premonition or a tech clairvoyance. And what they predicted happened. So there were predictors in yesteryears also. So you said that there were poor predictors, but in spite of that, there were real predictors of coming technologies. A technological clairvoyance was there with the Isaac Asimov and Clarke like persons. What is your take on it?
Yeah, so I'm also very scared of the tech convergence. This is unprecedented, and it's crazy how fast tech is disrupting the traditional way that we've been living for thousands of years. I think that the only solution is universal basic income. Y Combinator in San Francisco, which is one of the premium tech venture capitalists in the world, they have already piloted a universal basic income trial with, I think, like a couple thousand families in the United States, or maybe around the world. But yeah, they've trialed a couple universal basic income for a couple thousand families, ranging from, I think, $1,000 a month to a couple $1,000s a month, US. So what they're looking for is they want data points on how universal basic income impacts the people and the families that they're giving the supports to. So ideally, what they're looking to find is that if you're given a minimum basic income, then hopefully you don't do nothing with your time. Hopefully it encourages people to launch initiatives and to spend their time in. So if you don't have universal basic income and you just spend all of your time worrying where your next meal is coming, then you need to spend your time worrying where your next meal is coming. But if you are certain that you have a next meal, then you can spend your time giving back to the community and creating enterprise or creating startups and stuff. So they're looking for those kind of data points, and assuming that they get good data, I think in maybe next year in a short amount of time they're gonna expand the pilot to like 100,000 families to get more data points. But yeah, the universal basic income is something that especially tech entrepreneurs in Silicon Valley think is mandatory for how we deal with the coming tech disruption. And I think that with the introduction of robots and all of this technology, I think that there will be so much abundance because robots will be able to do a lot of the tasks that humans do. I think there will be so much abundance that the universal basic income will be something that is achievable. At least I hope so. But I'm bullish on it. I think it can happen. Pardon? Universal or a digital ID is a applicable thing. Digital ID brings value for your passport as one use case of digital identity on the blockchain. So today we have a physical object. If you lose your passport, you quote unquote, you lose your identity, which I think is ridiculous in today's world. I'm not sure about the how the process in India of what happens if you lose your passport. I lost my passport in Miami. To get a new passport, to get a new quote-unquote identity took me a couple days and a couple $100, which is crazy that you can lose your identity and then you need to spend time and money to get your identity back. So that's one use case. With the blockchain, you have your digital, you own your identity, you can't lose it. It exists forever. You don't need to pay to get it back. A second problem with digital identity is that I think, I'm not sure about India, but I think about 50% of Americans don't even own a passport, so they can't leave the US. With a blockchain-based digital identity system, everyone would have equal opportunity to have and own their digital identity. But passport is just one. When your driver's license is a second. When you board a plane, you have you have your plane identity. Anytime you're going to a conference, you have a ticket is your identity. So identity is a very broad blockchain use case. But the main innovation of the blockchain is distributed trust is trust, implicit trust in a distributed network. So you can do business with anyone around the world and guarantee that the person is going to be trustworthy. So that brings value in the supply chain. When, for example, you're doing import and exports, and you need to trust the person on the other side is going to carry their end of the bargain. With the blockchain, that's implicit. That brings value for medical records is another identity one. If you're sending someone payments internationally, then today we're reliant on a trusted third party that guarantees the trade. These trusted third parties take a large percentage of the trade to verify it. Using the blockchain, we can do that instantly for free. I could continue to brainstorm blockchain use cases. Yeah. Pardon? Is blockchain portable with containers? I'm not sure what you mean by that. Like, is it available in the cloud? The blockchain is portable, so you can put it on a cloud, like a AWS or Azure server, and then you can access your blockchain interface from anywhere in the world. Or you could have your digital wallet on your phone, and you can access that from anywhere in the world. Very portable. It's like the internet. It's available everywhere. Pardon? Right. So I think a crazy part of hospitals today are that I guess I go to a family doctor. We have free healthcare in Canada, which is awesome. I'm not. Do you guys in India have curiosity? No. Yeah. So my family doctor has my history of medical records until I turned 18, and then I went to another doctor that has my medical records from after 18. But if I travel, if I have to go to the hospital in India, they don't have access to my medical records. I don't even own my medical records. So the blockchain allows for you to own your data and for you to give up your data how you choose to. So that's like medical records is just one example of that. We use if you use Facebook, Facebook owns all of your data, and Facebook can sell it or do whatever they want with it, or advertise to you based on the data they know about you. With the blockchain, it gives back the ownership of the data to you, and you can choose when you sign up for a website or for whatever, how you want your identity to be, how much of your identity you want to be known. So you could sign up with either your phone number or your. It gives back control for your data to you and to the world. So let's going down memory lane a little bit. I would say the internet took off in 1993 after the introduction of I guess an affordable PC that people could put in their house. And since 1993, it's been 20 years for the internet to be in everyone's pocket, or I guess 2 billion people's pocket around the world, and for me to have Wi-Fi connection when I'm in the jungle of Thailand or the desert in Australia. And I think actually last week, Internet.org successfully released a satellite that would bring internet to the 4 billion people of the world that do not have Wi-Fi connection, or that do not have Wi-Fi connection in their area. So from the creation of the computer, which was early 1900s, to today, it was 100 years. But then really it was from the PC when it went mainstream to today, it's been 20 years. The internet grew very quickly, but for the internet to grow, we had to host stuff had to be on the best example of this from the past couple weeks is, I think, in March or April, the UN launched a pilot to use blockchain to distribute donations to approximately 50,000 people around the world, and using Ethereum. This pilot is going to change